Let's write it that way. Let's write it per cm. Per cm. Right?
Yep.
What else are we given? Or what are we looking for?
Well, you gotta get your conversions.
Well, we're looking for the fraction of the beam transmitted, right?
Right.
Yes.
Okay.
So we have our intensity formula.
Yeah, so we know we're going to use our intensity formula.
Well, I have somewhere in my note, if they give you mu, just times thickness.
What do you mean just times thickness?
If they give you mu,
Yeah.
just take that times your thickness and that's your answer.
Incorrect. How that? What, you tell me why that's wrong.
I don't know why that's wrong. I've got that in my notes.
From me?
No, from ARC.
No. That is absolutely incorrect.
Okay.
Because that would be that's what we've been discussing this entire time. It's like saying you have 100 photons, you lose 3%. This one's saying you use 4% per cm.
Okay.
So after 1 cm, how many would you have? If you had started with 100, you lose 4%.
4%.
So how much? You lose 4% per cm. So how much do you have after 1 cm?
96%.
96. Now you move another cm. How much do you have? It's not going to be 92.
Right.
It's going to be 4% of 92.
Right.
And that's
96.
the whole point of why we get an exponential
Right.
decay.
Right.
So what they told you would be a linear decay, which would be absolutely wrong.
Okay.
That is the entire essence of radiation therapies. Everything is an exponential, right?
Yeah.
I mean, this has to make sense. I mean,
Right.
if this does not make sense, seriously tell me now, because we cannot move forward past this. Does that make sense?
Yeah.
Because I will spend I'll spend another hour going over this if we need to,
Right.
because this is crucial.
Makes me laugh. This is it, folks.
So
I will slit my wrist.
Even though we all got a different answer.
Yeah, that is right. Okay, so we've
Okay.
got that. We're going to use our intensity formula.
we're gonna so what they basically 3 A B C D is just
The same formula.
it's the same formula, and he doesn't change mu. He makes you do the same thing 4 times with a different lens, basically, right?
Yeah. Right.
So what's the formula we're going to use?
I equals I-O-E negative mu x, which is your thickness.
X is your thickness.
Right.
Okay, so
Why did I do that?
we know our formula. So let's go to 3b. What have they given us? We've given us the mu, and they've given us what else?
2 centimeters.
2 centimeters.
Which is your
Thickness.
x. And they said, what is it? 2 cm. Right? So this is your given. And what are we looking for?
Your intensity.
We're looking for the
The
fraction.
beam, yeah.
So
transmitted.
the fraction being transmitted or the fraction left over. So there's a couple ways you can think about this. You can say, okay, if we're looking at the fraction, we can say I-O ols equals 1, and then I will be the fraction left over. Right?
Right.
Does that make sense?
Yeah.
Or you can say I over I-O equals fraction.
I guess I said I-O equals 100, thinking 100%.
Or you
Maybe
could do
that's
that.
right.
If you want to put in 100, you could say it like that. And then this would be not the fraction left over, it would be the percent left over. Right? Another way to say this is the percent that's transmitted. There might be 2 T's in there, I don't know. It's what is not stopped in that thickness that actually makes it through. It's the percent that actually goes through. Does that make sense?
Right.
Okay, so I'm just going to use for me it's easy for me to look at it as I equals 1. Sorry, I-O equals 1. I is what I'm looking for.
Okay.
That's the way I'm going to work all these problems, because that makes sense to me in my head. That gives me immediately the fraction. So for 3b, let's set up our formula. What would it be? Or I'll wait till you guys write down and then we can go.
Okay. For some reason, oh okay, we're gonna, okay.
But you did percentages.
Don't ask me because I got something totally, I'm waiting to see what happens because I can't figure out where I went wrong.
Well, you might not have
It's
gone
probably
wrong.
plugging
You
it into
did
your calculator.
percentages, so that could be right.
So
So I got, okay.
let's set up
So
B.
I equals
Okay, I equals
1
E, negative 0.04.
times 2, because that's our centimeters,
times 2.
on B.
Okay.
So
And
we
what's your
can,
answer?
0.923.
0.992 is what? Sorry, 0.923. Correct. Absolutely. Yes.
So I have 92%, so same thing.
yeah.
Okay.
Yes. Or if you were to put it in percent from here, you can just multiply by 100% equals
Gotcha.
92.3%.
Well, I'm not getting
Life
that.
is good.
Okay. So the reason I did B,
E's right?
I don't know.
the reason I did B first was because
No, you don't want to hit ln. You need to hit your E. You're not ln in the other
You
side.
can do second ln. That is your E.
Yeah.
Okay.
Yep.
Okay.
Yep.
Okay.
Yeah.
Okay.
You don't want to use just a regular ln. You need to use the E. You're thinking of the activity where we switch the sides sometimes.
okay, so let's do C. What would change?